Okay, if you look at the board, tomorrow we have a quiz and you're going to need your graphing calculator. Which means there are two problems on our homework where you needed a calculator, right? So either you're going to have one of them or both of them. There are 5 problems, 4 points each. And I will even tell you the first problem. The first problem is I'm going to give you the 3 vertices of a triangle. You're going to either have to find the centroid, the orthocenter, or the circumcenter.
I thought it was the formula.
But if you just use common sense, you know it's not going to be the centroid because it's too easy, right? Because there's a formula for that.
So
you know it's going to be either the orthocenter or the circumcenter.
On the quiz, are you going to explain what orthocenter and circumcenter is?
I already did. You guys have that in your brains already. Common knowledge.
Common knowledge.
Okay, why is my big quad worksheets always disappearing? Okay, so from now on, period 3 will not be videoed because we spent the whole class going over homework problems and we didn't even finish. So we didn't even finish, plus they didn't get a lecture. So the cycle is just going to start tomorrow again for them. Period 4, period 3, you're in trouble. I'm talking to you. I'm not sure what's wrong with period 3, but there is something wrong.
I left period 6. I watched a vid. Evan's so funny, yeah. He challenged you.
Okay, number 4. Okay, number 4. You know, and a lot of these problems can be solved if you just look at the examples. Did you guys look at the examples I made? A lot of them can be answered if you just follow the example. Okay, number 4. I wouldn't be surprised if this is on tomorrow's quiz. Okay, find the square roots of 3 plus 4i. In other words, what complex number squared will give you 3 plus 4i? In fact, I told you how to do it, right? Well, all you have to do is solve this equation. You solve this equation, the problem's done. I don't know how to solve this. Okay, let's go back to elementary school. If you have c plus di is equal to 4 plus 5i, what can you conclude? C is 4 and d is? Yep. That's all you got to know to do this problem. Does everybody understand that?
Yeah.
When you work with complex numbers, especially complex equation, the real part on the left got to equal to the real part on the right. The imaginary part on the left got to equal to the imaginary part on the right. Okay, so what you got to do is you got to expand this. You got to multiply this out. So a squared plus 2abi minus b squared is equal to 3 plus 4i. Can everybody do that? Can everybody like do the I squared part in your head? I squared is -1, so that's why it's minus b squared. Okay, now, exactly what I told you. In order for these two things to be equal, the real part on the left got to equal to the real part on the right. So what equation can I write? What's the real part for it? A squared minus b squared equals 3. And the imaginary part on the left got to equal to the imaginary part on the right. 2ab got to equal 4. 2 equations, 2 variables. This is algebra 1. Can you take it from here, or are you gonna fumble? You want me to? You want me to run for the touchdown? Give me the ball.
A squared minus b squared.
Because that's the real part. The real part is the stuff that doesn't have I in it. And
So I can't plug in 3 for a and 4 for b.
no, we want what complex number squared will give you that. See, if you didn't have the square, then you could just say a equal 3 and b equal 4, but there's a square there, so you got to simplify it.
Wait, can you solve a squared minus b squared?
Equal 3.
Yeah, like I
Like 2 and 1.
Oh.
You mean like that? 2a is 2 and b is 1.
Oh.
Well, yeah, you can do guess and check. Okay, but then what if I make the answer come out? Okay, what if a is 7 halves and b is something else? Like what if it's fractions or radicals? Who's going to guess and check that?
Do you solve for b on the equation?
No, you use algebra 1. How do you solve two equations, two variables? The normal procedure is you solve for one variable in one equation and then you plug it into the other, right?
Yeah.
Okay, so if I were me, this is what I would do. I'd solve for b in this equation. B equals 2 over a. Take that and plug it in here. So you get a squared minus 4 over a squared is equal to 3. How do I get rid of the fractions? Okay, so you get a to the 4th minus 4 equals 3a squared. Make one side 0. A to the 4th minus 3a squared minus 4 equals 0. Doesn't this have quadratic form? It's not a quadratic equation, but it has quadratic form. Whenever this power is double that power, and that's a constant, it has quadratic form. I think last year you guys did U substitution. But come on, we're past that. Just do this already. Don't need U substitution. Just go a squared and a squared minus 4 plus 1. Just factor it like a normal quadratic. So a squared is either equal to 4 or negative 1, but they cross this one out because... Well, no. When you have a complex number, a and b have to be real numbers.
Yeah.
Okay? You can't have like i's within the i's. A and b have to be real numbers. So that's why cross out negative 1. So therefore, a is equal to plus or minus 2. Oh, so got two answers then, Mr. Park. You bet your bippy. Okay? So, if a is equal to 2, what is b equal to? How do I figure out that?
1.
You plug it back into which one? This ugly one or the nice one? Okay, so if I plug in 2 for a, b is... If a is negative 2, b is... So your two answers are 2 plus I and negative 2 minus I. These are the square roots of 3 plus 4i. In other words, if I were to square each of these, you would get 3 plus 4i. Whoa, Mr. Park! Notice one answer is the opposite of the other one. Is that always going to be the case? Yes! Also, Mr. Park, if I guess the first one, I just negate it to get the second one. Yes! Does everybody understand why this is plus or minus 2? Because the other class did it.
Yeah.
You sure?
Yeah.
I don't think so. You guys, okay, we better go through this. If x squared is equal to 9, what are the solutions? Okay, y plus or minus 3? Okay, how do you solve this equation? You square root both sides. What is the square root of x squared? No, yay, 9, yeah! It's the absolute value of x. It is not x. It is not plus or minus x. That's just ludicrous. What is the square root of 9? No, it's just 3. It's 3. It's not plus or minus 3, it's just 3. So, what numbers do you absolute value to get 3? Plus or minus 3. So this plus or minus comes from the absolute value now. But see, when a lot of teachers show you how to solve equations like this, they usually skip this step. And that's why a lot of students think this is equal to x, and that's plus or minus 3, but that's actually two mistakes. You guys understand? That plus or minus comes from the absolute value. I think I showed you guys this in summer school if you read my class. But that just shows how much you retain. Okay, next. 4, 5. Ah, boo! Boo! So what should I do? Write out all 100 terms? This is like SAT right here. You look for a pattern. Nobody in their right mind is going to write out 100 terms. Oh, I did, Mr. Park. No. Okay, what if I go to 1,000? What if I went 1,000 I to the 1,000th power? Okay, Yama?
It's gonna be 1,000, 200. It's gonna be negative.
I stopped listening already.
500 minus.
No, I don't want to hear.
500 I. Right?
Excuse me, you said something?
Yeah.
Okay,
Yeah.
you look for a pattern. But in order to see a pattern, you actually have to write out a few terms here now. So I'll do the first one. I. Okay, simplify the next one. Matsubara. And then?
And then minus 3i. Then plus 4. Plus 5i.
Oh yeah, you're right.
Minus 3. Minus 7i. That's where I stopped.
Not plus 8?
Yeah.
Whoa.
Anyway, you guys know that complex numbers repeat every 4, right? So let's look at the first 4. If I add up, do you see the pattern? Positive, negative, negative, positive. Positive, negative, negative, positive, right? If I add the first 4, what do you get?
Negative 2i.
What?
Plus 2.
2 minus 2i. You write the real part first, like a normal person. You write the imaginary part first. Okay, what if I add the next 4 terms? 2 minus. Oh, here's the part. Every 4 adds up to 2 minus 2i. So if you have 100 numbers, how many groups of 4 is that? That's 25 groups of 4. So you just multiply this by 25 and that's your answer then, right? You look for a pattern. How come so many people are scribbling furiously? Kim? I didn't look for a pattern, that's why. People! Okay, whatever. Tomorrow's quiz, I think like period 3, I feel a lot of single digits tomorrow on the quiz. Hopefully you guys
Just
don't
like
do that.
10, yeah. Like that's when they're on double digits.
But how much is a quiz worth?
20 points.
Well, same thing then. Why would you be happy to get an 11? And 11 is 55%. Whatever. Rejoice then. Remember, my quiz problems are exactly the same as the homework. I change the number. That's all it is. The only way you cannot do it is if you didn't do the homework. You just copy off the board or something. Okay, number 5, which is fine. You won't get 100% on your homework grade, but then when you take the test, it's not going to be pretty. Okay, I'm just curious on problem. What about, because since it's not up there, problem 6F and G. I'm just curious how you did it. 6F. How did we do this problem? Did we do the barbaric way or the smart way? The barbaric way is, oh, I see a radical, I'm going to square both sides. Because what happens when you square both sides? What must be done at the end of the problem? You must check your answers because you could have extraneous solutions, right? You guys were taught that, right?
Extraneous?
Yeah, so instead of squaring both sides, it's like only square both sides if necessary. Why not just make one side 0, like this, and go, hey, that has quadratic form. This power is double that power, that's a constant, it has quadratic form. So if you want to do the U substitution that you were taught last year, right? What would you let U equal to? Yeah, root x. Whatever this is, that's what you let U equal to, right? You were taught that. But come on, we're beyond that. Just do this already. Just root x minus 4 plus 2. So therefore, root x is equal to either 4 or negative 2, but I'm going to cross that one out. How come? Yeah, because you cannot square root a real number and get negative 2. Okay? So, what number square rooted will give you 4? You really have to think about that one. 16. And I don't have to check my answers because I didn't square both sides. But ultimately, I don't care how you do the problem. The reason why I put these problems here is just to see, I'm curious on how you're solving problems. Are you diving into the pool without even looking, or do you actually look to see if there's water? Okay, now what about G? Did everybody square both sides on that one? Yeah, that one you kind of have to, right? But then did you guys check your answer? Okay, guys, this is what period 3 did. Well, first of all, most of them didn't even do this problem. Okay, but here's G. They do all the work and they get their answers. What were the 2 answers? X equals 2/9 and 2. And this is what they said. Oh, I look at the bottom of the page. Only get 2/9 there, so I guess I gotta cross that one out. That's period 3. Did you guys do that? You guys know why you gotta cross out 2? Because when you plug it back into the original equation, it comes out false. It comes out 3 equals 5, which is false. Now, when you have the answers on the bottom, it's easy to do the homework. So what's going to happen on the quiz when no more answers on the bottom? Well, we'll find out tomorrow. Because tomorrow is the first real quiz. It's not like logic, because it's all baby food, right? Now you got to actually chew. Okay, number, oh, very good. I like that. Okay, I'm curious on 7b. Did you guys do the smart way or the dumb way? I think we better do 7b. How come I don't? How come just because you got the problem correct, you can still write it on the board because maybe there's a faster way. Because if it took you like 10 minutes to do problem 7b, that's probably not the best way to do it, right? So shall we do 7b? So that means that if I walk around the room right now, everybody did 7b then. You're starting to sweat under the arms now.
Let's do 7B.
Write it on the board. How hard is that? My dog could write. Okay, 4x squared plus 8x plus k. Okay, how do you determine what kind of roots you have? You look at the discriminant. The discriminant is b squared. I'll just put b squared minus 4ac. This is the discriminant. And if we want rational roots, the discriminant has to be a perfect square. So if you simplify this, you get 64 minus 16k, and I want that to be a perfect square. And so the problem is, okay, what integer values between negative 10 and 10 will make this a perfect square? So this is what period 3 did. Well, the two people that tried it, the other people didn't get there yet. Okay? They plug in negative 9. So basically, you got to plug in negative 9, negative 8, negative 7, negative 6, all the way up until positive 9, right? Okay, plug in negative 9. Go. Well, see, if you actually did the problem, you would have shouted out the answer, right?
208.
Okay, 208. Is that a perfect square?
No.
No. Okay, negative 8. 192. Is that a perfect square?
No.
Negative 7. Mr. Park, it's kind of hard to plug in, yeah? Because some of you are having arithmetic problems, yeah? Some of you don't even know that 208. You couldn't even get that even with a calculator. There's no calculator on this problem. So maybe, Mr. Park, there's an easier way. Duh. How about, instead of plugging into this, why not factor out the 16? What happens if you factor out the 16? You get 4 minus k. Now, why is this beneficial? Because 16 is a perfect square. Since 16 is a perfect square, the only way that the whole thing can be a perfect square is this got to be a perfect square. So instead of looking at this gargantuan thing being a perfect square, you only have to check this now. 4 minus k is a perfect square. Now isn't that a lot easier to plug in negative 9, negative 8, negative 7? Yeah, who wants to plug it into that when you can plug it into that? But like I said, if that's the only thing you know, then if the only tool in your tool belt is a tiny hammer, then that's what you got to use, right? Okay, can you do it now? Can everybody plug in negative 9, negative 8, negative 7, all the way to 9? Yeah. Doesn't matter, Mr. Parker, just copy down what's on the bottom. Okay, you want to play that game? Easy for me. I'm just warning you guys now. When I look at the homework, if I see fake work and then the answer appears, I take a triple. Take a triple. So if you really don't know how to do something, it's better to just leave it blank. But then why would it be blank when you can write any number on the board? Okay, whatever. Okay, number 8. Okay, here we go. This is a good problem. Oh, you guys did 8A. Okay, ax squared plus x minus. So basically I'm asking, what are the values of a so that you can factor this thing? Well, if you can factor this thing, doesn't that mean it has the equation equals 0 would have rational roots? And in order to get rational roots, the discriminant must be a perfect square again. So what is the discriminant? E squared minus 4ac. That's got to be a perfect square. So 1 plus 24a equals a perfect square. So in problem A, I'm asking for the 5 smallest positive values of a, positive integer values of a. So if I plug in 1, is that a perfect square?
Yes.
2,
Yes.
yeah, and so forth and so forth, yeah? You guys can get that, right? Okay, now B. Find the 3 smallest values of a that are greater than 100, but you can use a calculator. So you've got the double asterisk. Okay, so what is the first number I should plug in? What's the first integer bigger than 100? You really have to think about that one. Huh? 101. Okay, so I let you use a calculator. Plug in 101. How do you determine if that's a perfect square? What do you do? You square root it. And then what are you looking for? If it's into a whole number, right? So if I plug in 101 and then square root it, if it's a whole number, then that's a perfect square then, right? Okay, let's do that. Plug in 101. It didn't work, Mrs. Park. Okay, then 102, 103. It's good. Mr. Park, even with a calculator, the thing is taking long. Well, duh, maybe you're not, yeah. You gotta use your calculator efficiently. You don't use it like a rabid mad dog. Now, is there a way you can tell your calculator, plug in 101, 102, 103, 104, and square root it really fast, and produce those results in a table? Yeah, we make a table. That's what we're gonna do. Your calculator can make tables. You just gotta feed it the formula. Okay, so if you have a TI who has TI and who has Prism? Okay, TI calculator. Okay, you gotta know where the table is. Look for the table button. It's on the top. Prism people, you gotta go to the main menu, and then I think table is in the second row somewhere. Am I right? Okay, go with the table. Okay, TI people, press the Y equal button first. Are you following? Press the Y equal button, you should see this, Y1 equals. So you have to tell the calculator, what's the formula I want to plug in the numbers into? Well, it's the square root of 1 plus 24x, right? This is the formula. Except we're using x as our independent variable and not a. Now if you have a prism, you go to table and then you enter it. Doesn't the y1, y2, y3 come out already? And then you just punch this in. Except on the prism it looks like this, yeah? Square root of 1 plus 24x, and then come out of it. Come out of the radical. I believe on the prism, see I'm not really familiar with the prism yet, but isn't there a button x theta t?
Yeah.
That's your independent variable button. So if you press that, the x will come out. Okay? Does everybody have that formula in now? Okay, now, before you use the table, you gotta set the table. Don't just press the table button. 84 people, TI people. I bet some of you did already. Nothing else, I know you did. Okay, you gotta set the table. So, TI people, go to table set. Now, those of you with Prism, if you look at the bottom, isn't one of the options set? How come some people saying yes, some people saying no?
Oh,
Yeah, after you enter it. And set. Okay, now, TI people, what do you do when you go into the table set? What's the first thing it says? Table start. What does that mean? What is the first number you want to plug into this formula?
101.
101. Delta table. What increments do you want to go in? I want to go in increments of 1, right? 101, 102, 103. And then the last two things should say automatic. Now press the table button.
where do we end?
Oh, you can end, well, you start at 101, I would go up, because you don't know how many you're going to look for. I mean, go up to 1,000 then. So with Prism people, I would go from 101 to 1,000. That's what I would do. Now press the table button. And then you should see something that looks like this. X, Y1, 101, 102, 103, 104. So basically what's happening? Your calculator is plugging these numbers into the formula and it's spitting out the answer. Ka-two, 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 ka-two. And then you just keep scrolling down, hold the down arrow, keep scrolling down, and we're looking for a whole number, right? So when is the first time I see a whole number? 117, then okay, that's the first answer. Keep scrolling down. When do I see the next whole number? Wait, let me look at the bottom of the page. 126, and then 145, where it should be, right? If you did it correctly. See, isn't this a lot better than just manually plugging it in one at a time? Yeah, this is how you make it. That's when you make a table. Some of you are eating without utensils. You guys are like barbarians. But at least it's better than nothing. You're getting fed, right? Those of you who are not doing anything, you're not getting fed. You're starving. So what if tomorrow I said, find the, on the quiz, all I do is change numbers. So instead of a 6 here, maybe I'll put a 5 instead. Or 7. But since I told you that, it'll be 8. But since I told you that, now it'll be 9. And then find the 5 smallest values of A, no, 3 smallest that are greater than 100. But since I told you that, it'll be 200. But does it really matter what number I use? If I say greater than 500, then you can put table start 501, right? Doesn't matter. The calculator is going to do all the number crunching. Okay, that takes care of that. So, what are the 2 problems we did on the calculator you better be ready for tomorrow? Best fit straight line and this, make a table. Usually every quiz there's going to be 1 or 2 problems where you get to use your calculator. The other is no calculator. Like tomorrow, number 1, find the coordinates of the orthocenter or circumcenter, definitely no calculator. But you guys practice on your homework, right? Well, I copied it off the board. Well, then good luck. Look, if you're lucky enough where I tell you this problem's on the quiz or test, then you better mark it down. And if you didn't do it, you better practice it. Unless you're really, really good at math, right? You just pick it up. Are we doing number 9? Yeah, 9B. Wait a minute, time out. How can you do 9A but not 9B? That's so strange. That is the strangest thing I've ever seen in my life.
There's only one answer for 9A.
There's only one answer for 9A and 9B. No, there's an infinite number of answers actually. But if you reduce the equation down where the leading coefficient is positive, then there can only be one answer.
Maybe a fraction.
No, yeah, it could. That's why there's an infinite number of answers. Okay, let's just do number 9. I believe I gave an example of this in the examples. There's an example. How come, see? You guys better look at the examples, especially if we don't finish the lecture. Okay, which one you want to do, A or B? I'll do one of them. I think we better do B because the other class, I don't know. The other class is just I don't know, period. Write a quadratic equation where these are the roots. And it got to be reduced. There are no fractional coefficients either. Well, there's several ways of doing it. Like if you didn't know anything, a lot of people, they just use the quadratic formula and go backwards, yeah? And they make it fit. You know what I'm talking about? You know like how the quadratic formula, the denominator is 2A, so you go, oh, A must be 1. You know what I'm talking about? So yeah, you can do that, okay, but what happens when the numbers get large, and there's like fractions and radicals and stuff like that? Okay, look in your notes. What is the significance of these 2 things with a quadratic equation? Here's a quadratic equation. Okay, there you go. Negative b over a in a quadratic equation is always equal to the sum of the 2 roots. C over a is always equal to the product of the 2 roots. This is super important now. Every Algebra 2 book and pre-calculus book, this is in it, but you guys probably never pay attention to it. But this is important as you will find out later when you do the harder problems. You know what, the other class, they're getting confused with negative b over 2a. What is negative b over 2a?
Oh, vertex.
Yeah, that's today's lesson. That's the x-coordinate of the vertex of a parabola. Negative b over a, though, that's equal to the sum of the 2 roots of a quadratic equation. So, if we know these 2 things, okay, here are the 2 roots. Add them together. Go. Period 3 triplet combinations to add them. I'll give you a hint, the eyes cancel out. It rhymes with me. 3. What is 3 over 2 plus 3 over 2? 6 over 2, which is 3, right? Oh my goodness. Okay, now multiply the 2 roots, the product of the roots. C over A is equal to the product.
Five over 2.
5 over 2. What? Okay, look, when you multiply, you're going to get 9 minus I squared over 4, right? 2 times 2 is 4. But I squared is negative 1. So 10 over 4, isn't that 5 over 2? Okay, so if you cannot add and multiply, pretty much you're done for, yeah. Okay, so we need to find the values of A, B, and C. Now look at the numbers that you have here. What would be a good number to let A equal to? 2. If A is 2, C would be 5, right? If A is 2, what is B? Negative 6. Therefore, the quadratic equation is 2x squared minus 6x plus 5 equals 0. Box that, that's the answer. So that's the way most books teach you. Most books will teach you this method. They don't teach you use the quadratic formula backwards. Everybody understand that?
Yeah.
But you have to know that negative b over a is the sum of the roots and c over a is the product. If you don't know that. Now, however, there's a math team secret. This is what we do on the math team because we're special forces. Watch this. Did I show the math team method on the example? I did. Some of you don't even know there's examples there. Kojima. Why do I make these examples? I spent half my career making it and you guys just don't even look at it. Just like the cheat sheet for SAT. I know everything already. Okay, now watch. Watch what I do. This is so beautiful it's going to bring tears to your eyes. Okay. Now I'm gonna. You want me to just show you the quick way, or you want me to break it down step by step? Because if you do it step by step, it's not that impressive. Okay, watch this. I think you can follow because we're honors, right? 2x minus 3 equals plus or minus I. You see what I did there? I multiply both sides by 2 and then I subtract 3. So basically, I'm isolating the radical thingy, right? I is the square root of negative 1. Okay, square both sides. 4x squared minus 12x plus 9 is equal to negative 1. So therefore, 4x squared minus 12x plus 10 equals 0, reduced by 2. 2x squared minus 6x plus 5 equals 0. Woo! Yeah!
Whoa, that's good. Answers.
Wait, let me look. Yeah! Whoa! Actually, this one took an extra step because we had to reduce it. Usually, you just get the answer right here. Right? You gotta reduce your answers. You guys see how that works?
Yeah.
Basically, what's happening here? This is the reverse of, what am I doing backwards? Okay, what if I give you the quadratic equation? What if you go backwards, how do you get the roots right there? What am I doing? This is the reverse of completing the square. He's doing it backwards. See, so this works on anything. Okay, here, let me show you. So now that you're armed with this is like a pistol right here. No, when you're special forces, when you go into combat, you just want to have a knife. Is that all you need? If you only have a knife, you gotta have like firearms. So watch this. Okay, I'll do A for you. Using the math team method, watch this. So 3x minus 2 equal plus or minus root 5. Right? You guys can do that in your head. Square both sides. 9x squared minus 12x plus 4 is equal to 5. Therefore, 9x squared minus 12x minus 1 equals 0. Finished. This is a pistol. It's not like a bazooka or a rocket launcher or anything like that. We'll have some of those later. This is like a pistol. See? Isn't that fast? Yeah.
And half x squared minus 2x minus half, right?
Say that again.
Half x squared minus 2x minus half minus 2x. I mean, like the second one's minus 2x.
Equals 0. No. That's not the same equation.
Why not? Because I might.
Well, if I multiply through by 18, you can see they're not the same, right? Look, if I multiply through by 18, you're going to get 9x squared minus 36x minus 18 equals 0. That's not the same. It has to be the same equation or a multiple of it, but everybody should reduce it and the first term should be positive, right? Mr. Rubash taught you that, right?
Minus 9.
Where? Yeah, but this is just wrong anyway, okay?
Wait, even if I got it, like I did it backwards,
What?
Ah, never mind.
Okay. What? What? No, just if you listen to me, I'm giving you the most efficient ways. Yeah, but if you put a pistol in your tool belt, you gotta make sure it works now. So if you have the pistol but no more bullets, then what? What's gonna happen? Yeah, but what if your opponent has a pistol that works and you have a knife only? What? Block it with the knife. Well, then you better hope the muzzle velocity is very low.
Oh, shoots.
Okay, tonight's homework, okay, see, we're gonna get a lecture. Other class, no more lecture. Okay, what are we doing? Okay, basically you gotta, okay, now, last year, you guys, I know, you guys graphed a lot of parabolas, but tonight I only give you one. Okay, okay, here we go. Let's review how to graph. Okay, what if I tell you to graph, okay, I don't want to make the same one. Y equal 2x squared, no! Minus 2x squared plus 8x minus 5. Okay, I need to make up something. Similar to your homework then. What's the fastest way of graphing a parabola? Well, first of all, these are the two forms of a parabola, right? Y equal ax squared plus bx plus c. Or you have y equal a times x minus h squared plus k, right? Which one is the more useful one? The second one, right? Because that, Mr. Rubash called it vertex form.
Yeah.
That's because the vertex of the parabola is at hk. So that's a more useful one. So one way to do it is to put it into vertex form by completing the square. Does that sound familiar from last year?
Yeah.
However, we learned last year it's way faster to use negative b over 2a. Anytime you have a parabola, the x-coordinate of the vertex is going to be, right here, negative b over 2a. How do you figure out the y-coordinate? Yeah, just plug it back in, right? You guys remember that, right? Negative b over 2a. So, what is negative b over 2a in here? Negative b over 2a. Oh, 2! So the x-coordinate of the vertex is 2. To get the y-coordinate, you just plug it in and go. What do you get? Negative 8 plus 16 minus 5 rhymes with me. 3. So the vertex is 2, 3. Oh, yeah. So 3, 2, 3. Now when you graph, did I already tell this class? When you put hash marks, I assume each hash mark is 1 unit. So you don't have to label. You know how like some teachers go, you gotta go 1, 2, 3, 4. No. Every hash mark, if you don't do anything else, I assume it's 1 unit. If you change the scaling though, then you gotta give me a hint. Like if you did this, like that's 18, then on the y-axis each hash mark is 6. But if you don't put anything, I assume 1. This is saving you time. Nakayama, what's so funny? Which way does this parabola open? Up or down? It opens down. So can I just plot the vertex and do this? No, that's not good enough. You got to be a little bit more accurate than that. What's another fast point that you can plot?
0.
No, yeah, the y-intercept. That's the y-intercept, right? When x is 0. What is the y-intercept?
Negative 5.
Yeah, this number here is the y-intercept, right? Because if you plug in 0 for x, that's what you get. So the y-intercept is negative 5. But a parabola has symmetry. So if I go 2 this way and down there, if I go 2 that way, I got to be down there hard. Now you can just go, wah! Yeah! See, now that's a pretty accurate graph, right? Isn't that? See, when you go to calculus, see, when you're in algebra 2, the graph, that's the final answer. But when you go to calculus, this is just part of the answer. That's to help you get the answer to a problem. Okay? So you have to be able to graph things quickly, because then you got to move on to do other stuff. Okay, so that's the fast way of graphing parabolas. Okay, and then the rest, pretty much the rest is you have to write an equation of a parabola if I give you some information. Okay, so here's a typical problem. Write the equation of a parabola with vertex at 3, 2, and it passes through the point -1, -4. So here, let's draw a picture. You don't need to draw a picture, but I just want to show you what's going on. The vertex is at 3, 2, and it passes through the point -1, -4. So we want to write the equation of the parabola that looks like that. So what? What do I do? Should I use this form or the second form? Yeah, if you know the vertex of the parabola, you should use the vertex form. Okay, so since I know the vertex is 3, 2, the equation is going to be a times x minus 3 squared plus 2. Don't forget to put a square. A lot of people forget to put the square. And they get a lot of points off because then that's not a parabola anymore, it's a line, right? Yo, Mr. Park, how do I figure out a? Oh, since the parabola is opening down, just put negative. Yeah, but how do you know it's -1? How do you know it's not like -2, -3, or negative, could be a -1/2 or something? How do you figure out what a is? This is like SAT. You plug in a point that you know. So we know this point here, -1, -4. If I plug in -1 for x and -4 for y, I can figure out what a is, right? So -4 is equal to 16a plus 2. 16a is equal to -6. A equals -6/16, which can be reduced to -3/8. So therefore, the equation of this parabola is y equals -3/8 x minus 3 squared plus 2. Box that, that's the answer. Yes, because if it doesn't say what form to leave your answer in, you can leave it in any form. But don't worry, on the test I'm going to tell you what form to leave it in. So what if on the test I ask, write it in this form? Then you gotta multiply it all out. But would I do that for you?
No.
Maybe. Okay, so tonight's homework, this is easy. Come on. The only one you would have trouble with is problem number 3, but I'm not going to tell you how to do it. I just want to see what you do. I want to see what your level of mathematical prowess is. You guys know what tangent to if you have a line tangent to a parabola, you know what that means? Well, this doesn't have to be the vertex. Like if you have a line that is tangent to a parabola, that means it touches it at one point like that. That's tangent. Okay, that's number 3. And I'll tell you, that problem's going to be on the test. But of course, it's not that easy. We start slowly. Okay, we're done. We're covering in 2 minutes. At least we had a lecture. I'm wondering what's wrong with period 3. Period 3, if you're watching, you guys better think what's wrong with you. Because some of them are going to want to watch because they didn't get a lecture.
Hi, Sam.
Wait, who's in period 3?
Period 3, I don't want to mention any names.
I'll try again. I still don't get the answer to this.
Well, isn't sine just going to be b over radical dash? And cosine is a over radical dash. Just plug it all in.
Yeah, but it doesn't look like what the answer is supposed to be.
Oh, that's because I changed it. See?
Sometimes the test is like the test accidentally made a mistake. So
Oh yeah, sometimes when I